Now, to start us off, I will start, the first thing that I'll do is I will write formulas down, and I'm asking you to also write them down so that as we continue to do this this subtopic, we are going to be applying them as we do examples. So, andika mahali, distinguish the formulas for arithmetic progression and distinguish the formulas for geometric sequence, geometric progression. Now, the general equation for an arithmetic progression is given by an is equals to a1 plus n minus 1 d. The sum, this is the general equation. For the sum, sijui kama my work is clear. If it is not clear, please let me know. Inaonekana? Yeah. So the sum of an arithmetic progression ama sequence is a1 plus an is divided by 2 multiplied by n. We will see what this n and d mean in a few. D is given by taking a2 minus a1, which should be equal to a3 minus a2. This is when you have successive terms. When you don't have successive terms, you can also be able to find d by taking ay minus ax divided by y minus x. And to find the mean of an arithmetic progression on a sequence is a plus b divided by 2. For a geometric progression, the general equation is given by an is equals to a1 multiplied by r raised to n minus 1. The sum, which is usually denoted by s, is given by a1 multiplied by 1 minus r raised to power n divided by 1 minus r. R is given by a2 over a1, which should be equal to a3 over a2, and this is for successive terms. If you don't have successive terms, you don't have numbers ambazo zinafuatana, then the r is given by y divided by ax. And the mean of a geometric sequence is given by the square root of a times b. Now, what do these things mean? Hizi ambazo tunaandika. Now, let's start with the arithmetic progression, the arithmetic sequence. This an is that value, this a is just a way of denoting a number. Yeah. So for an arithmetic progression sequence, a certain term an, the nth term, is given by a1. A1 is the first term in that sequence, plus into brackets n. N denotes the number of terms. How many numbers you have in that sequence, minus 1, multiplied by d. D is the common difference. And we will see that in a few minutes. Yeah. So d is the common difference, n is the number of terms, 1, 2, 3 is just the position of the term. So for 1 is the first term, a2 is the second term, a3 is the third term, an is the nth term. So if you have 20 terms in that sequence, then n will be 20. Now, how do we find the common difference if you have successive terms? Yeah? When I mean successive terms is that you have number ambazo zinafuatana. So a1, a2, a3, a4, a5. So for an arithmetic progression, a2 minus a1, the second term minus the first term should be equal to the third term minus the second terms. If you had 5 terms, then A5 minus A4 should be equal to A4 minus A3. Yeah? So that difference between those two numbers that are successive or that are next to each other in that arithmetic sequence gives you what we call the common difference. If you don't have numbers ambazo zinafuatana, then you can be able to still find the common difference by taking AY minus AX. AY is that, and we will see. We will see with examples. Acha hii tutaacha tuone kwa examples. The mean, how do you find the mean? Ama the average. You'll just take that term plus the second term divided by 2. For a geometric sequence, ama for a geometric progression, AN, the nth term, is given by the first term, A1, multiplied by R. R is the common ratio. Yeah? Common ratio, what do I mean by the common ratio? If you have successive terms, if I take the second term divided by the first term, should be itanipatia a ratio, a common ratio. If I take the third term divided by the second term, it will give me a common ratio. R means common ratio. If I do not have successive terms, I can also be able to find a common ratio. If we will see this. These are examples ambazo hazina successive terms. We'll see them in a few. Now, the mean of a geometric sequence is A times B, and then you find the square root. Now, najua tumeandika formula mingi, but let us see. Now, you've been given an equation. AN is equal to 2n plus 5. AN is equals to 2n plus 5. And you're told to find the first 4 terms. Find the first 4 terms. So we want to find A1, we want to find A2, we want to find A3, and we want to find A4. Now, how are we going to do that? We will take the value, we will confirm the first term, we will replace the 1 in the value of n. Remember, n denotes the number of terms. Yeah? So A1 will be 2, replace 1 in that mali ambapo n iko plus 5, to give us that the first term is 2 plus 5, which is 7. The second term is that you will plug number 2 in mali n iko. So 2 times 2 plus 5 to give us 9. The third term will be, you plug number 3, the 3 in where n is. So 2 times 3 plus 5 to give us that the third term is 11. The fourth term, we do the same. Plug number 4 where n is to give us that the fourth term is 13. Now, the sequence that we have here is 7, 9, 11, and 13. That is the sequence that we have. Now, we can be able to identify whether this sequence is an arithmetic sequence or a geometric sequence. And how do we do that? For an arithmetic sequence, you'll find that the difference between these numbers should be equal. What do I mean? This is A1, A2, A3, A4. If I take A2 minus A1, which is 9 minus 7, the difference is 2. If I take A3 minus A2, which is 11 minus 9, itanipatia bado 2. Therefore, this sequence that we have here is an arithmetic sequence, an arithmetic progression. If I had 20 terms, labda 7, 9, 15, whatever, the difference between those two successive terms will still give me 2, therefore denoting that this is an arithmetic progression. Now let us do another example and see the difference between an arithmetic and a geometric sequence. We have been given this equation. AN is equals to a third raised to n. AN is equals to a third raised to n, and you're told to find the first 4 terms. Now, how do we find the first 4 terms? A1, A2, A3, and A4. We will plug 1 for A1 where n is, so therefore this will be a third raised to 1. For A2, we will plug a third where, we will plug 2 where n is. A3 the same, we plug 3 mali n equal, and A4 the same. we plug 4 n, we plug 4 where n is supposed to be. Therefore, a1 is a third raised to power 1, which is a third. a2 is a third squared, giving us 1 over 9. a3 is a third cubed. Yeah? A third cubed gives us 1 over 27. And a4 is a third raised to power 4, which gives us 1 over 81. Now, this is a geometric sequence or a geometric progression, because a third, a ninth, 1 over 27, and 1 over 81. This is our sequence, and it is a geometric progression. Why? When we take the second term and you divide by the third term, it should give you the same ratio. 1 over 9 divided by 1 over 3 should be equal to 1 over 27 divided by 1 over 9 should be equal to 1 over 81 divided by 1 over 27. And what ratio do we get when we take when we divide those numbers that are successive? Kwa mfano 1 over 9 divided by 1 over 3, it gives us that the ratio is, what do we get? 1 over 3. That is a common ratio. If I take 1 over 27 divided by 1 over 9, you find that the ratio is still the same, 1 over 3. If I take 1 over 81 divided by 1 over 27, I will still get the same, a third. Meaning that this sequence is a geometric sequence. It cannot be an arithmetic sequence, because if I take 1 over 9 minus 1 over 3, it will not give me the same value by, when I take 1 over 27 minus 1 over 9, and we can confirm that right now. 1 over 9 minus 1 over 9 minus 1 over 3 gives us 2 over 9. If I take 1 over 27 minus 1 over 9, inanipatia negative 2 over 27, meaning that the difference between these successive numbers is not the same. So this is therefore not an arithmetic progression, but a geometric progression. Are we together? Tuko pamoja? Are we together? Kuna swali mpaka hapo? Naona watu wamenyamaza sana. Let me see. Benjamin, are we together?
Yes, I'm following, sir.
Dennis Onditi, unaona ameingia late, but uko na sisi? Peterson, are we together? If you're with us, please unmute and say that I'm present. Ili niweza kujua kama we are in class. If you are, so we were just trying to identify what is an arithmetic sequence and what is a geometric sequence. For arithmetic sequence, the common difference between those two numbers should be the same. I mean, between successive terms should be the same. Upper. And if my work is not clear, please let me know. Kama mwezi ona niambieni tafadhali. Yeah, for an arithmetic sequence, these terms, the difference between these two numbers is the same. So 9 minus 7 is 2, 11 minus 9 is 2, 13 minus 11 is 2. For a geometric sequence, when I take when I divide the successive terms, the numbers that follow each other, this is the first term, the second term. If I take A2 divided by A1, I should get the same ratio by if I take 1 over 27 divided by 1 over 9. This becomes a geometric sequence. Now, we may also be able to find how do I say this? Now let's try another example. Kama an is equals to an minus 1 plus 5. We have been given an equation kama hiyo. An is equals to an minus 1 plus 5. Now, this is usually known as a recursive formula. This is known as a recursive formula. A recursive formula is one that has a recursive formula ni ile ambayo iko na hii. Ukiona mahali kwa a in an equation and you have n minus 1 mahali, that becomes a recursive formula. So we have recursive formulas for AP and we have recursive formulas for GP, and we will be able to see the difference. Now, mfano kama hii, you have been told to find the first 4 terms given that A1 is 8. You're told to find the first four terms given that A1 is 8. Now, for recursive formulas, you have to be given the first term. Now, how do we do this? We are told that A1 is 8. Now, therefore, A2, we plug 2 where n is. So A2 is A1, so 2 minus 1 is 1. So A1 plus 5, okay? And we have been given that A1 is 8. This becomes 8 plus 5. So the value of A2 is 13. A3, we plug 3 where n is equals to A3 minus 1, which is A2 plus 5. And the value of A2 is 13. So 13 plus 5, which gives us 18. A4, we plug where 4 is, mali n equal, to give us that 4 minus 1 is 3. So A3 plus 5. And A3 tumeona ni 18. So 18 plus 5 to give us that the fourth term is 23. Now, the numbers in our sequence are therefore A1, which is 8, A2, which is 13, A3, which is 18, and A4, which is 23. Now, I want you to tell me whether this is a geometric sequence or an arithmetic sequence. Is this a geometric or an arithmetic sequence? This is an arithmetic sequence because the difference between these successive terms is the same, and the difference in this case is 5. The common difference is 5. 13 minus 8 gives us 5. 18 minus 13 gives us 5. 23 minus 18 gives us 5. Okay? Therefore, okay.
I didn't get it how you are treating the one.
Where?
How you treated the one, the minus 1. So can you just please pardon so that I can get it clear?
Nilisema, you might be given equations ambazo that have this n minus 1. You remember that these 2 examples that you have just done before, the general equations ni mfano hii an 2n plus 5. This is just a normal equation, a normal algebraic equation. But when you have equations ambazo ziko na n minus 1, now this is known as a recursive formula, ama a recursive equation. Now, when you're told to find the first 4 terms of this mfano kama hii, it is possible. Now, most of these questions ambazo ziko na recursive notation, you're usually given the first term. So you're told find the first 4 terms of this equation given that the first term A1 is equal to 8. Now, if you replace now 1 here, A1 is equals to A1 minus 1, which becomes 0. Utapata kwamba it is impossible to find that term. That's the reason why you are given the first term A1 is equals to 8. But it is possible to get the second term by taking 2 and you plug it into this n, mali n equal. So A2 is equals to A, so 2 minus 1 becomes 1. So A2 is equals to A1 plus 5. But remember we had been given A1 as 8. So A2 is 8 plus 5 to give us 13. The same with A3. You replace A3 mali n equal, you plug it. So A3 is equals to A3 minus 1, which is A2 plus 5. And A2 tumepata before that A2 is 13. So A3 is 13 plus 5 to give us 18. And so on and so forth. If you're told to find the first 20 terms, then it is possible. Now, when you look at this formula, I mean this sequence, then it is possible to come up with a general equation for a general recursive equation for arithmetic progressions, which is an, the nth term will be given by an minus 1 plus the common difference. Are we together? Kwa mfano in this question unaweza ambiwa find the 20th term, the 100th terms, I mean the 200th term, A200. What will be the value of A200? You cannot continue writing A1, A2, A3, A4, A5, A6 mpaka 200. No, it will take a lot of time. That's why we have a general equation which can help us identify the 1,000 terms, the 200th terms, the 50th term. Kwa mfano in this recursive arithmetic progression, the 200th term will be A99, which we do not know, plus the common difference. Are we together? So the general formula of a recursive arithmetic progression is ni hii hapa. So you can write it down mahali. This is the general equation. The general equation of a recursive arithmetic progression. Let us look at an example for a geometric progression. You're told this is an equation umepatiwa. an plus 1. an plus 1 is 2an. an plus 1 is 2an, given that a1 is equals to 3. You're told to find the first 4 terms of that this geometric progression. And this is a recursive geometric progression because we have this in our equation, an plus 1. Now, we already have the value of a1. So a2 A2 itakuwa ngapi? I want you to help me. Replace where 2 is. I mean where n is with 2. Anyone? Anyone? I want us to find the second term. How are we going to do it? What have we done to this n plus 1 to get 2? Tumefanya nini kwa n plus 1 to give us 2? We have taken n to be 1, so the value of hapa itakuwa 1 to give us that a2 will be equal to a1. I don't know whether you are seeing this. A3, what will I do to this to get 3? I will take 2 plus 1. So a3 is equals to, we have replaced 2 kwa n, is equals to 2 a2. The fourth term, a4, I've taken n to be 3, so 3 plus 1 to give me 4, is equals to 2, then this will be 3, a3. Are we seeing? So that the second term, a2, will be 2 times a1, and a1 we had been given as 3, becomes 6. A3 is 2 times a2, so 2 times a2 na tumepata a2 as 6, so 6 to give us 12. A3, 2 times a3, and a3 is 12 to give us that the fourth term is 24. Therefore our sequence is 3, 6, 12, 24. We have been able to find the first 4 terms of our sequence, and this is a geometric sequence because if I take these 2 successive terms and I divide a2, this is a1, a2, a3, and a4. If I take a2 divided by a1, it gives me 2. If I take a3 divided by a2, it gives me 2. If I take a4 and a3, it gives me 2. So this is a geometric sequence, ama geometric progression. So I want you to see the similarity in this recursive geometric and arithmetic. For geometric, what we are doing is we are taking the common ratio. We are taking the common ratio R. This is a common ratio R, which you have seen is 2, and we multiply it by the previous term to get the next term. Kwa mfano A2 will be 2 times A1. A3 will be the common ratio times the previous the previous term. A4 is 2 times A3. Therefore, we can also be able to find the general equation. The general equation of a recursive geometric sequence. Itakuwa that the nth term will be equal to the common ratio multiplied by an minus 1, or an plus 1 is equals to the common ratio times an. These two formulas mean the same thing. So this is a general equation of a recursive geometric sequence. For arithmetic sequence, the general equation for an recursive arithmetic sequence is an is equals to an minus 1 plus the common difference. So for me to get the next term is I'll take the previous term and add the common difference. Kwa mfano A1, to get A2, I took A1 plus 5, the common difference. To get A3, I took A2 plus the common difference. That is for arithmetic progression. For recursive geometric progression, to get mfano A2, I took the common ratio multiplied by A1. To get A3, I took the common ratio times times A2. Are you together? Tuko pamoja. I want people to ask questions if there are questions. Msinyamaze. If you have any questions, please ask as we continue. If you are together, please unmute and say that you are with me. Are we present? Are we present? Peterson, uko na sisi? Class rep, are you with us? Sherry lanjo uko na sisi. Kuna mtu ana swali mpaka hapo?
Yes, sir.
Uliza kama kuna swali. Kuna swali? Okay. Okay. Now, we have two sequences over here. The first sequence is 2, 6, 10, 14, 18. And the second sequence is 2, 6, 18, and 54. I want you to tell me which one is the arithmetic and which one is the geometric sequence between the first sequence and the second sequence. Ni gani the first one and the second one? Between the first one and the second one, which one is an arithmetic and which one is a geometric sequence? Yes? The first one is an arithmetic sequence because the common difference between successive terms is 4. So this is 4, the difference between these two terms is 4, the difference between those two terms is 4, and the difference between those two terms is 4. The common difference is 4. This one is a geometric sequence because when I divide successive terms, I'll get that the ratio, the common ratio is 3. 6 divided by 2 is 3, 18 divided by 6 is 3, 54 divided by 18 is 3. Now, you have been given these sequences. Kwa mtihani umeulizwa, write the general equation for these two sequences and find let's say the 20th term. Kwa mfano, let's start with the arithmetic progression ama the arithmetic sequence. Umeambiwa find the general equation of this sequence and then find the 20th term. Find the general equation and then find the 20th term. Now, tutafanyaje hiyo swali? Now, remember this is an arithmetic progression ama arithmetic sequence. And for an arithmetic sequence, the general equation is an, the nth term, is given by the first term plus n minus 1 multiplied by the common difference. Are you together? The nth term is given by the first term plus the number of terms n minus 1 multiplied by the common difference. Therefore, an for equation over here, an will be given by the first term in our sequence hapa ni ngapi? 2. A1 is 2 plus we don't know how many terms our sequence has, so n minus 1, but we know the common difference between the successive terms. Now the common difference is 4. Therefore, an will be 2 plus, we open that bracket, 4n minus 4. Therefore, the general equation of this sequence is 2 minus 4 is minus 2 plus 4n. Let me rewrite it as 4n minus 2. Are we together? Those are the type of equations ambazo tumekuwa tukifanya. Kwa mfano, this example that we started with, we have been given the general equation an is equals to 2n plus 5, so that you're told to find the sequence. But you might be given a sequence and then you're told to go back and find the general equation, and that's what you are doing. We have the sequence and you're told to find the general equation of that sequence. So tumepata that the general equation of this specific sequence is an is equals to 4n minus 2. That is part 1 of the question. Part 2 of the question is asking us to find the 20th term. The 20th term. So A20, the 20th term, itakuwa ngapi? So you plug 20 where n is in our general equation. Is 4 multiplied by 20 minus 2. So the 20th term, if we continue writing our sequence, you will find that the 20th term, itakuwa 4 times 20, which is 80, minus 2, to give us that the 20th term in our sequence is 78. Are we together? If you have to write down this sequence 2 4 hivyo mpaka ufike the 20th term, utapata that the 20th term is 78. Sawa sawa? Now let us try this one, the geometric sequence. Yeah, we told the same question: find the general equation and find the 20th term. Now remember that the general equation of a geometric series, a geometric sequence, is given by an is the first term a1 multiplied by the common ratio raised to n minus 1. Therefore, an will be given by, now what is the common ratio what is the first term? What is the first term in our sequence? 2. You multiply it by the common ratio. The common ratio in this case is 3. Raised to n minus 1. We don't know how many terms our sequence has, so for the general equation, tunachanga n. Okay? We don't input n. We only input n when the question asks you to find the 100th term, the 20th term. Now, the general equation will therefore be this will be our general equation. An is 2 times 3 multiplied by n minus 1. Now, we have been told to find the 20th term. What will be the 20th term? So, the 20th term in this case will be 2 times 3 raised to 20 minus 1. We plug 20 where n is. Therefore, the 20th term in this geometric series, in this geometric progression will be tunapata ngapi? What answer do we get? What will be the 20th term in this geometric sequence? Calculators itabidi tuzitoe mahali tumeziweka. What will be our 20th term?
It's a very huge now.
Yeah, hiyo huge number itakuwa ni hiyo. Isome tu.
2, 3, 4.
2, 3.
2, 3, 2, 4. 5, 2, 2.
5, 2, 2.
9, 3, 4.
9, 3, 4. So this is 2,324,522,934. Now you see, when you're doing this progression, then you might not be able to write 5. Tumepata hii kila mtu. Yeah, so you see, it is impossible to start writing A1, A2, A3, A4, A5, A6, A7 mpaka 200. I mean mpaka 20. You'll find that the numbers zitaendelea zikiwa kubwa na kubwa na kubwa na kubwa. So if I tell you to find A100, the 100th term in that sequence, then the number will keep on increasing and increasing. That's why we have to first find, the first thing that you do in this, when you're given the sequence, you first find the general equation of that sequence. First find the general equation of that sequence. Once you find the general equation of that sequence, then you plug the nth value. The nth value in that formula. In this case, tumeambiwa 20, so you plug 20 in that formula. If you are told to find the 8th term, kwanza, let's find the 8th term. Tumeambiwa find the 8th term in this sequence. What will be the 8th term? What will be the 8th term in that formula? What will be?
6,374.
Unapata ngapi? 437.
4,374.
It is 4,374. And what have we done? We have replaced the term 8 where n is supposed to be. So plug 8 here. So 2 raised to power 3, 2 times 3 raised to power, so 8 minus 1 is 7. So 3 raised to power 7 inakuwa ngapi? Is 2187. We multiply by 2. Gives you that the 8th term in our sequence is 4,374. So the first thing that you do is generate a general equation of that formula, of that sequence, and then plug the value, the nth value. And remember that the general equation of an arithmetic sequence is an is equals to a1 plus n minus 1 times the common difference. The general equation for a geometric sequence is an is equals to a1 multiplied by the common ratio raised to n minus 1. So once you find the general equation, then it is easy to find the term. Now, what I had introduced before, your recursive formula, is not something that you need to msijisumbue nayo sana sana. In the exams that I've seen, Zanek, they don't have those types of questions where you have the recursive formulas, but it is also important to understand them. Sawa. Kwa mfano, let's look at this these two. Tuangalia this equation. I mean this sequence 2, 6, 10, 14. And you're told to find you write it this, you represent this in recursive form. You represent it in recursive form. Remember that the general equation of a recursive formula. Now, before taniendele, is this a geometric or an arithmetic progression? Or a sequence?
Arithmetic sequence.
It's a arithmetic sequence because the common difference between these numbers ambazo zinafuatana is 4. The common difference between successive terms is 4. Now, remember that the general equation of a recursive formula for an arithmetic sequence is given by an is equals to an plus 1 plus the common difference. Okay? This is the general equation of a recursive arithmetic sequence. Now, the general equation now for this specific sequence itakuwa ngapi? An is equals to an plus 1 plus 4. No, D is 4. The common difference is 4. Are we together?
Yes.
So, if I was to find so this is not the general equation of that recursive arithmetic sequence. In that, the geometric sequence in our previous example, if you're told to find the general equation for this sequence, you still do the same. Remember that the general equation of a recursive geometric sequence is given by an is equals to an minus 1 times r. So the general equation of this specific sequence, geometric sequence, itakuwa an is equals to an minus 1 times 3. Are we together? Tuko pamoja? But hii mambo ya recursive isiwasumbue sana sana when you are doing our exams. What I just want you to see is how to go from the sequence to get the general equation, and how to get from the general equation to the sequence. That is what we have been doing with the examples. In the first examples that we did, you are given the general equation of that sequence. So you find the sequence itself. That was for the arithmetic. For the geometric, you are given the general equation, and you want to find the sequence. Now, the subsequent examples tumekuwa tukifanya is that you are given the sequence, and you're told to find the general equation of that sequence. Sawa. So you should be able to move from the sequence to the general equation, and you should also be able to move from the general equation to the sequence. Sawa. Kuna swali mpaka hapo?
So, Mwalimu, are you trying to say we should master these formulas?
Hizo formula ni muhimu sana. For arithmetic, you have to find, kama mfano this arithmetic, kama hii hapa. When you're given the general equation of this is a general equation you have been given for that sequence. You are told to find the first 7 terms. It is easy kwa sababu you'll just be plugging the 1, 2, 3, 4, 5 to get the terms. Okay. Lakini kama umepatiwa a sequence kama hii, sequence kama hii hapa, it might have 22, 26, 30. It might have 10 terms. Kwa mfano, you must be able to find the general equation of that sequence. Are you together? Kwa sababu the general equation of this sequence is not the same as the general equation this sequence, but both of them are arithmetic sequences, lakini general equation ya hii ni tofauti na general equation ya hii. But the formula we apply for both is here. That is the general equation of an arithmetic sequence. If you're given a geometric sequence, the common ratio here is 3. You might find the common ratio is a half. The common ratio is a quarter. Therefore, the general equations of these specific geometric sequences will be different. But the general equation of a geometric sequence itakuwa ni hiyo. So using this general equation for the geometric sequence, then it is possible to find the general equation for these specific sequences. So these two are very important. These two equations, hizi mbili, they will help you determine the general equation of those specific sequences depending on the numbers that you have been given. Sawa.
Yes.
Now, what you've been doing is finding now, for example, if you're given, now kwa mfano umepatiwa a fraction, you're told to find you have been given a sequence that is fraction, that is a fraction in nature, fractional in nature. The same rules still apply. The first thing is you find the general equation of this specific formula, and this question specifically is asking us to find the 12th term in that sequence. Now, the first thing we have to do is to determine whether this is a geometric sequence or whether it is an arithmetic sequence. Now, how do we do this? How do we tackle fractional sequences? What we do is we separate the numerators and we separate the denominators.
Mwalimu network iko na shida vibaya sana.
Network yangu ina shida?
Na katika
Amunisikia ama ni hapa muoni?
Tunaona lakini sasa ukiongea unastaga vibaya sana.
Okay. Let me change, niweke bundles zingine nione kama itasaidia. Sasa mnanisikia? Kukiwa na shida tafadhali mniambie kwa sababu nisijipate naongea peke yangu. Thank you class rep for letting me know. Now, you have been given a fractional sequence and you have been told to find the general. Now, you're told to find the 12th term of this sequence. Now, for fractional sequence, the thing you do is you separate the denominators and you separate the denominator and the numerators. You deal with them separately. Now, for the numerator uko na 3, you have 5, you have 7, and you have 9. Is that a arithmetic or a geometric sequence?
Arithmetic.
It is an arithmetic sequence. Kwa sababu the common difference is 2 between the successive terms. Now, how do we write the general equation of an arithmetic sequence? The general equation of arithmetic sequence ni?
An is equals to A1
plus minus 1 D. That is the general equation for an arithmetic sequence. In this case, the common difference for this specific sequence is 2. And the first term is 3. Therefore, the general equation of this specific sequence will be AN is equals to 3 plus n minus 1, common difference is 2. So an is 3. When you open these brackets, it nakuwa 2n minus 2. So our common equation, the general equation of this sequence is 2n plus 1. So this is the general equation for the numerator. Turn the denominator. The sequence is 4, 8, 16, and 32. 4, 8, 16, and 32. Now, is this a geometric or an arithmetic sequence?
Geometric.
It's a geometric sequence.
Geometric.
Because when you divide successive numbers, unapata that the ratio is 2. Yes, sindio? Now, what is the general equation of a geometric sequence? Is equals to A1 common ratio. A1 times common ratio raised to n minus 1. In this sequence, the common ratio is 2 and the first term is 4. Therefore, the general equation for this sequence is 4 multiplied by the common ratio 2 raised to n minus 1. Are we together? Therefore, the general equation for this sequence, the general equation for this fractional sequence, itakuwa the general equation for the numerator, which is 2n plus 1 divided by the general equation for the denominator, which is 4 to n minus 1 raised to n minus 1. Are we together?
Yes, sir.
The general equation of a fractional sequence will be given by the general equation of the numerator divided by the general equation of the denominator. Now, the question is asking us to find the 12th term. What is the 12th term? So what do? We will plug 12 mali n equal. So A12 will be given by 2 multiplied by n, which is 12, plus 1 over 4 times 2 raised to 12 minus 1. So what will be the value of the 12th term? Hmm? 12 times 2 is 24 plus 1 to give us 25, divided by 2 raised to power 11. 2 raised to 11 gives us 2048, and multiply it by 4 to give us 8192. That will be the 12th term of this sequence. Na hii tuko pamoja?
Yes.
Any question? Kuna swali? Let us do this example here. You have this sequence 1 plus 4 over 8 plus 9 over 27 plus 16 over 64. I know it is possible to simplify this. This will be a half, this will be a third, this will be a fourth. But I want us to use this example as it is. Now, what do? This is a fractional sequence. We first separate the numerator and the denominator. Okay? 1 is 1 over 1. As a fraction, 1 is 1 over 1. Now, for the numerator, the sequence itakuwa 1, 4, 9, and 16. For the denominator, the sequence is 1, 8, 27, and 64. Now I want you to look at this very carefully. Will this be an arithmetic or a geometric sequence?
Geometric.
Which one? Let's start with the numerator. Numerator ni geometric ama ni arithmetic? When I take 4 minus 1 inanipatia ngapi? 3. When I take 9 minus 4 inanipatia ngapi? 5. When I take 6 minus 9 inanipatia ngapi? 7. So that is not a it's not an arithmetic sequence, because the common difference between these successive terms is not the same. This is 3, this is 5, this is 7. Tuangalie kama ni geometric sequence. 4 divided by 1 ni ngapi? 4. 9 divided by 4 is 9 over 4. 16 divided by 9 is 16 over 9. Therefore, this is also not a geometric sequence, because the common ratio is not the same. It differs. But look at this. I want you to see this very, very carefully. The numerator is something we call, these numbers are something we call perfect squares. They are perfect squares. 1 square gives us 1. 2 squared gives us 4. 3 squared gives us 9. And then 4 squared gives us 16. These are perfect squares. Therefore, it is easy to say that the general equation of the numerator is n squared. Kuna ile pattern ambayo inafuata is that you are taking the square of a term. Therefore, the fifth term will be 5 squared, which is 25. Sijui kama tunaona hiyo pattern. Look at the denominator. It is neither a geometric or an arithmetic sequence, but it is a perfect cube. 1 cubed will give us 1. 2 cubed will give us 8. 3 cubed will give us 27. 4 cubed will give us 64. Sijui kama tunaona hiyo. Therefore, we can assume, with regards to this pattern, then the general equation for the denominator is the cube of that term, of that number, n. Therefore, the general equation of this fractional sequence hapa juu yetu is n squared over n cubed. Are we together? The general equation for this sequence will be an is equals to n squared over n cubed. Sio kila wakati utapata sequence na it will be geometric ama arithmetic. No. When you get a sequence and it is neither a geometric or an arithmetic sequence, then you'll just write in the exam that it is neither. So you cannot continue with your calculation. But it doesn't mean that you can't have such examples that have perfect squares and have perfect cubes. In this example, you have a perfect square and you have a perfect cube. The perfect squares for the numerators, and you have perfect cubes for the denominators. With the numerators, that pattern can be summarized as by the general equation an is n squared. And for the denominator, that pattern can be summarized by the general equation an is equals to n cubed. Therefore, the general equation of this fractional sequence of ours, 1 plus 4 over 8 plus 9 over 27 plus 16 over 24, its general equation will therefore be n squared over n cubed. Okay? Now, if you're told, for example, you find the 10th term in that sequence, it will therefore be 10 squared over 10 cubed to give us that the 10th term will be 100 over 1,000. Are we together? If we are together, if you're in this class, please unmute and say that I'm present.
I'm present.
Present.
Have you been able to
So
see?
you just leave it, you can't simplify.
No, we can simplify, but I wanted you to see an example that has perfect squares and perfect cubes. Sawa. Now, what if you have been given, for example, an arithmetic sequence, but it doesn't have successive terms? Kwa mfano, you have been told that A1 is 8, A4 is 29, and the question is asking you to find the 17th term. You have A1 as 8, you have the 4th term as 29, and then you're told to find the 17th term. Now, before I continue, is my work clear? Inaonekana? Okay. You're told the first term is 8, the second term is 29, and you're being asked to find the 17th term. But it is an arithmetic sequence. Now, remember, we've been saying that when you're given a sequence that is arithmetic, A1, A2, A3, A4, and so on, A5, that the difference between successive terms should give you the common, should be equal, okay? The common difference between successive terms should be equal if it is an arithmetic sequence. So A2 minus A1 should be equal to A3 minus A2 should be equal to A4 minus A3. Now, in our example over here, we have A1 as 8 and we have A4 as 29. So for us to get from 8 to 29, we have added A1 plus a common difference to get 2. We have taken A2, we have added a common difference to get A3, and we have taken A3, we have added a common difference to get A4, and that A4 is 29. So for us to get from A1, we have added 3 common differences, the first one, the second one, and the third one, to give us A4. Are you together? Therefore, A1, which is 8, when you add 3 common differences, will give us 29. Therefore, the common difference in this situation will be 3D is equals to 29 minus 8 to give us 21, and the common difference will be 7. So we have been able to find the common difference in this sequence. Therefore, the first term is 8. The second term will be, A1 will be 8. The second term, A2 will be 15. The third term will be 15 plus 7, which is 22. And the fourth term, we have already been given as 29. So we have been able to find the common difference, and then it is also possible to find the other terms. But remember, the question is asking us to find the 17th term. Now, I had given an equation before that if you're not given successive terms, then it is possible to find the common difference by taking AY minus AX divided by Y minus X. This Y and X refer to this A1, A4. In this case, we had been given A1 and A4. Yeah, so the common difference will be A4 minus A1 over this 4 minus 1. I don't know if you are seeing this. Tunaona na tunaelewa. Kama kuna swali muulize, kwa sababu when you keep silent I might be talking to myself. Now, I was saying, if you're not given successive terms, then it is also possible to find the common difference. Kwa mfano, this is easier. Hii tumeweza kufanya namna hii kwa sababu the terms are not so far away from each other, A1 and A4. But maybe umepatiwa A1 and A20. Then it is possible to find the common difference by taking AY, now in this case A4, minus A1 divided by 4 minus 1. The value of A4 is, what is the value of A4? A4 is 29, minus A1, which is 8, divided by 4 minus 1, which is 3. Therefore, the common difference will be 7. Okay?
Mwalimu, hebu rudi nyuma kidogo kwanza. Hapo kwa common difference hapo mahali umeandika y minus x over y minus x is equal to hapo sasa hapo.
Hapa. Haya.
Hapo sasa hebu rudi hapo.
Angalia our question over here. We have been told to find the 17th term, and this is it is an arithmetic sequence. You're told to find the 17th term given that the first term is 8 and the fourth term is 29. The other examples tumekuwa tukifanya, we have these terms zimekuwa listed 1, 8, 17 zimefuatana, but we don't have successive terms. We have A1, which is 8. We don't have A2. We don't have A3. We have A4, which is 29. So it is not possible for us to say that A2 minus 8 is, we won't be able to find the common difference kwa sababu hatujui the value of A2. But it is possible to find the common difference by, in this case, angalia hapa. A1 is 8, A4 is 29. So from the value of 8, we have added the common differences, 3 common differences. So A1 plus D to give 8 plus D to give us A2, A2 plus D to give us A3, and A3 plus D to give us 29, which is the fourth term. Now, A1, therefore, plus 3 common differences should give us the fourth term, A4. The first term is 8, plus 3 common differences should give us the fourth term, which is 29. Therefore, it is possible to find that the common difference in this sequence is 21 divided by 3, which is 7. But this is easy to do kwa sababu it's easy to confirm because we have been given a sequence whose easy numbers inakaribiana. The first term and the fourth term are not too far from each other, so it's easy to confirm. But if you are given, for example, A1 is A1 is 8 and A4 is 3065. So it is not possible to keep on saying A1 plus A2 is like itakuwa kazi mingi sana. The more than the terms increase, then the more this value will increase. So what we do is we take that the common difference. If you do not have successive terms, this is if you don't have successive terms, hazifuatani, will be given by AY minus AX is over Y minus X. AY being the value of ile term ambayo ni kubwa. If I'm given, in this case, ile term ambayo ni kubwa ni A4, between A1 and A4. So AY will be A4 minus AX, which is the first term, or the smaller one, divided by Y minus X. In this case, Y will be 4 and X will be 1. So the common difference in this sequence will be A4 minus A1 over 4 minus 1 to give us 7. On it sijui kama tumeelewana hapo.
Nafuatilia.
Tumeelewana? Acha tutaona an example tukiendelea. Now we have the common difference. The question is not asking us to find the common difference. The question is asking us to find the 17th term. Now, the first step, step number 1, write the general equation for our sequence. What will be the general equation? Remember that the general equation of an arithmetic sequence is given by an is equals to a1 plus n minus 1 multiplied by the common difference. we have the value of A1. So AN is equals to, A1 was 8. So 8 plus n minus 1, and the common difference we have calculated and found it to be 7. Therefore, the general equation of our sequence is 8 plus 7n minus 7. And when you simplify this, inakuwa 7n plus 1. This is the general equation of our sequence. Therefore, the 17th term will be 7 times 17 minus 1 to give us that the 17th term is, this is plus 120. Are we together?
Yes, sir.
Tuko pamoja?
Ndio.
We've been able to find the 17th term by finding the common difference. Remember, we don't have successive terms. So even if we don't have successive terms, then it is possible to find the common difference by using this formula. AY minus AX over Y minus X. That should give you the common difference. And once you have the common difference, then find the general equation of that sequence, and then you find the term ambayo umeambia utafute 20th, 100th, 50th. Sawa sawa. Okay. Let us look at a geometric series, a geometric sequence that doesn't have successive terms. We are told that A1 is 48, A5 is 3. This is a geometric series now. We are told to find the 10th term. You have A1 as 48, you have A5 as 3. What will be the 10th term? So this is a geometric progression of a geometric sequence. Now, look at our terms. We have A1, we have A2, we have A3, we have A4, and we have A5. A1 is 48 and A5 is 3. Now, remember that when you divide successive terms, what you get is a ratio, a common ratio. Now, what have we done from 48 to get to 3? We have divided, or we have multiplied A1 times R to get A2. A2 we've multiplied by R to get A3. We have multiplied A3 times R to get A4, and then you have multiplied by A4 times R to give us A5. Now, A1 has been multiplied by R 4 times to give us A5. A1 has been multiplied by R 4 times to give us A5. We have the term A1, which is 48. We don't have the common ratio, and that is what we want to find. But we have the third term, the fifth term, which is 3. Therefore, the R raised to power 4 is equals to 3 over 48. Therefore, the common ratio between those successive terms will be, you take the fourth root. The fourth root of 3 over 48. Itakuwa ngapi? I want us to find the fourth root of 3 over 48. Okay, let us do it this way. Mambo ya indices. R raised to power 4 is equals to 3 over 48. Now, what will I do with what will I raise R raised to power 4 to give me R1? When I raise R raised to power 4 by a quarter, what happens? Laws of indices. When I raise a number that is already has a power, then this can be written as 4 times 1 over 4. Tunakumbuka hiyo? We are trying to eliminate this 4 so that we are left with r. So when you raise 4 with a quarter, then these powers multiply each other. So 4 times a quarter gives us 1. So we do the same thing on this side. We raise by 3 over 48 by a quarter. So when we take 3 over 48 and we raise it to a quarter, what do we get? Get a half. So the value of a common ratio is a half. Sawa? Okay. I'm assuming we are together. So what we have done is we have taken, yes?
The process.
Tumepatia these two numbers. We have A1 as 48 and we have A5 as 3. We have been told to find A10. Now, when we write our sequence down, A1, A2, A3, A4, and 5, the first term being 48 and the fifth term is 3. Now, for us to move from A1 to A5, we have to be, remember, A2 divided by A1 is R, A3 divided by A2 is R, A4 divided by A3 is R, and A5 divided by A4 is R. Now, for me to move from the first term to the second term, if A2 over A1 is equals to R, A2 therefore will be A1 times R. So for me to get A2, I will take A1 multiplied by R. For me to get A3, I will take A2 multiplied by R. For me to get A4, I will take A3 times R, and so on and so forth. Now, for us to move from A1 to A5, I will take A1. Remember, I have multiplied R 4 times. A1 times R times R times R times R to give me A5. So this is the same as saying A1 multiplied by R raised to power 4 to give me A5. Are we together? We have the value of A1 as 48. I have multiplied that R 4 times. We have multiplied 48 with the common ratio 4 times to give me the value of A5, which is 3. Therefore, the value of the common ratio can be found by taking the fourth root of 3 over 48. And an easier way of doing that without using your calculator is by using the indices. Ile property ya indices ambayo tulikuwa tumepitia in our first class. When you have a power raised to, when you have a number that is raised to a power and then you raise it to another power, that means that the powers multiply each other. So in this case, if I want to get R is equals to 1, what I will do is I will take R is equal raised to power 4 raised to a quarter. So that when these powers multiply each other, 4 times a quarter, this will give me R raised to power 1. So what I've done on this side, I do it on the other side. So 3 over 48, I raise it to a quarter. To give me the, when I raise this 3 over 48 to a quarter, I get that R is equals to a half. If that is too complicated, then you can just use your calculator and you find the fourth root. And how do you find the, yes?
The fourth root of 3 over 48 is 1.
Is 1. This is how you find it. You take 4. If I want to find the cube root, in our calculators, kuna square root, we have the cube root. But if I want to find the fourth root, the sixth root, the 20th root of a number, then I will, for example, in this case, I want to find the fourth root. I will take 4, press shift, and then I press this. Mahali kuna hii figure, hii hapa ambayo iko na x square root. That x represents the root I want to find. In this case, it's 4. So 4, press shift, and then press this button. Okay, so the fourth root of 3 of 48 should give us a half. Sasa Cheryl. Now we have the common ratio. The question is not asking us to find the common ratio. The question is asking us to find the 10th root of this sequence. Now, what do we do? The first thing we do is we find the general equation of this sequence. Now, remember that the general equation of an arithmetic sequence is given by... No, I've forgotten something. Now, what I wanted to show is that you can be able to find the common ratio of a sequence that doesn't have successive terms. We can say r y minus x, r raised to y minus x is equals to ay over ax. In this case, the value of y is 5, the fifth term, and the value of x is 1, is equals to the value of ay, which is the fifth term, which is 3, and the value of x, which is 48. This should just give you, should take you straight to the answer without having to do all this. So r raised to power 4 is 3 over 48, so it is possible to find r. Or r is equals to ay over ax raised to 1 over y minus x. Inakupeleka direct. As long as you have the value of the y, this term, and it is possible. In our example, the fifth term is 3, and the first term is 48 raised to 1 over the 5 minus 1 to give you 4. So you can be able to find the common ratio of terms that are not successive by using this formula. And this is for a geometric progression. These formulas are the same. So. Now, the question was not asking us to find the common ratio. The question was asking us to find the 10th term. Now, let us find the general equation. Yeah. So the first term, the second term, the third term, the fourth term, up to the 10th term. Now, the first term is 48. So what will be the second term? 48 times a half to give us 24. The third term will be 24 times a half to give us 12. The fourth term will be 12 times a half to give us 6. And we can continue like that until you get the 10th term. This is easy kwa sababu the number of terms ni kidogo. But if you had been given, let's say, the 50th term, you cannot go taking each number and multiplying it by a half. So you have to generate a general equation. Now, the general equation of a geometric series, a geometric sequence is an is equals to a1, the first term, times the common ratio raised to n minus 1. Therefore, an is given by the first term in our sequence is 48 multiplied by the common ratio, which is a half, raised to n minus 1. Now that is the general equation. The 10th term of our sequence will therefore be given by 48 times a half raised to 10 minus 1. So we just plug 10 where n is. Therefore 48 raised to a half times a half, which is raised to 9. The value of our 10th term will be what will be the value of our 10th term? Three over 32. Sawa. Any question? Kuna swali? Now I will stop there for today so that when we meet next time tutamalizia mambo ya these sequences on Tuesday. Yes, on Tuesday, so that on Wednesday we can be able to begin. Yes. Kuna swali?
Okay.